Hello all, welcome to the project text characterization using speech recognition. So now in this project we'll learn that how we can use speech recognition libraries to basically convert the speech spoken voice or the spoken audio files into a text array, basically a text array. So our main motive will be that we will see how we can extract text from voice or speech samples and use it to do text analysis using Python. So now this project is also based on the audio domain project. So this will give us a brief idea of how we apply machine learning in audio files. So now what is speech recognition? The speech recognition is an interdisciplinary subfield of computer science and computational linguistics that develop methodologies and technologies that enable the recognition and translation of spoken languages into text by computers with the main benefit of searchability. So now as I said that what speech recognition is nothing simply but what we do is everything which we are speaking is then converting into a text format. For example, I am speaking here, okay. Now if I'll use a speech recognition software, a speech recognition library, so whatever I am speaking, every word will be converted into text so that it can be analyzed for other further regions, and it has many different applications also. And the as I said that the service is provided in many different companies like Google, Amazon, IBM. We'll see in the notebook section that what are these libraries and how and what all these we can use, and also obviously some of which are paid, like the companies like the IBM and Amazon and Google Cloud also. Some of the all these libraries are paid because they do a wonderful work in explaining or transforming the speech to text categories. So these are used by many different companies all around the world, many different products all around the world to basically convert the speech to text in real time data. So speech recognition has various applications as I discussed earlier. We'll see some of them. Some of them are, one is the voice dialing. What you do in your phones, okay, you only say dial Raghav, dial Lokesh, so it will automatically dial it. But how is that possible? What is happening is that speech is converted to text. Its speech is getting converted to text. Now the further performance are happening in that, okay. Another one option is search keywords. Whatever you say in your phone which has a voice assistant, you'll say search keywords, then it'll automatically search all the keywords. Voice assistant cars, call routing, domestic appliance control, all the like the Alexa, the Amazon which is using, and all of the different things. The if some of the in our time the TVs are also voice assisted. So these are all the work, the wonder of speech recognition. Okay, so now moving on. In this project what we'll do, this is an introductory project of speech recognition, that how we can extract text from an audio file and perform analysis. These are some of the analysis, like we'll be finding out what are the unique words spoken per minute, how many times a word can be spoken. So this is something called text characterization, like this text which you are saying and what is the characteristics of that text. If the text is containing a vowel, if the text, how many words are there, how many words does that person spoke in 1 minute, all of these things comes under text characterization. So now moving on, the timeline of the project will be, first obviously we'll be loading the file. I'll be showing you how we can load the file. Then we'll be seeing different speech recognition libraries or the services which are provided. Then we'll be seeing the APIs which are used, okay. Then we'll perform speech recognition, then we'll perform the text analysis based on that. So let's begin. Hello all, welcome to the notebook section of our project, that is text characterization using speech recognition. So now in the previous introduction video we saw that what is speech recognition and why is it used for and what are the applications. So now this is a notebook section. In this we'll be performing the speech recognition using Python, and the very first thing which we'll be doing is we'll be seeing what speech recognition is and what are the different companies that provide it. So now as written here in this project, we'll see how we can use speech recognition libraries to characterize audio speech files by importing or just by saying them. We'll see how we can perform different operations on a speech to text converted data. So now the timeline of the project will be like, first we'll be importing libraries, we'll be using speech recognition, we'll be observing the audio files, and we'll be analyzing the data. So now the very first thing, the very first libraries are pandas, numpy, These are the two basic libraries which we use every time in a machine learning project. Pandas is for basically making the data frame, working with data frames. NumPy is to perform the mathematical operations. So now the very important library for our project is the speech recognition. This library is itself present inside the Google Python. That's why I'm importing it like such as import speech recognition as SR. So now remember, this project which I am doing, it's inside the Jupyter notebook. Now you can also perform this using the Google Colab environment. If you don't know about Jupyter notebook, Jupyter notebook is a basic local running environment ID. It is an in ID just like any other ID, like PyCharm or Visual Studio Code. So it is run in an offline mode. While if your computer does not have that much computational power, you can always use Google Colab. What Google Colab will do, it will run all of those things in the Google server, and you'll be provided with an internet CPU and GPU, so that there will be no lag in the performance. This that is the only difference. And the one thing is, in order to read files in Google Colab, you have to import them in your drive, because obviously it is working with internet, and in Jupyter notebook you don't have to do such thing. It will directly run it, because all of the libraries and things are present in your local machine, and you can do this in without internet. But in Google Colab you require internet connection. All of the rest things are same. This is the same interface which Google Colab also have, so there is not much difference. And the one of the more important benefits of Google Colab is all the libraries are pre-installed. In Jupyter, what happens is sometimes you have to install a library. So like if I want to install Librosa library, so what I have to do, I'll have to first install the Librosa library in Google Colab. It can be possible that it will be present automatically, and some of the libraries are also not supported in Jupyter. So it is always better to use Google Colab if your computer is not having much computational power or any of that sort. Okay, so now moving on, the as we are talking that import speech recognition as SR. So this is the library which we'll be using. We'll just use this, and the another one library is import IPython display as IPD. So now this library is used to basically read your files, just like you read the data frame in your Jupyter notebook. It is used to read or to play your files, audio files in the Jupyter notebook itself. Like example, if I'll say mid music, I'm an IPD dot audio, and then I'll pass my file. This is my file which is present in my root directory of my Jupyter notebook. I'll just pass this. Then when I'll see, I'll type here music. So when you'll see now, as you see that my audio file is here, I can listen to this audio file.
Then
Okay, let's fight it. And before explain further,
So now what this audio file is, this audio file is basically a conversation between two people, and what we'll be doing, we'll be extracting that audio, all the text, all the words that they have spoken into a text format. Okay, so now this was the importing library part, and the next time what we'll see that what are the different APIs which are used in speech recognition, and how we can use that speech recognition further. Hello all, welcome to the next section of this video. Previously we have seen the introduction to speech recognition and how we can import speech recognition and the audio files. So now in this section, what we have to do is we'll see that how we can apply speech recognition and what are the processes and the different things involved in it. So now the very first thing is, as you know that we have imported speech recognition as SR. So now the very first thing you have to do is you have to assign your recognizer. Okay, like when you just import your library, like when I import linear regression from sklearn.linear regression, import linear regression, then what I said that I assign a value to it, like LR is equals to linear regression and comma, that means that variable is assigned to that particular thing. So similarly here also I am saying recognizer is equals to SR dot recognizer bracket. So now my recognizer has now become a particular variable which will do all the work for me. So now instead of calling out different one again and again this recognizer class, I have assigned it in a variable. So now what we'll do, I'll just allow my speech recognition to read my audio file and give its name. So now when you see that the type of my audio, this is my audio file. Okay, the type is audio file. Okay, so now what we have done is we have successfully read our data, and we have successfully loaded our data. So now the time is the APIs. So now as you said, there are different APIs. There are different APIs. I'll tell you one second. The APIs are like IBM, CMU, Google Web Speech API, Google Cloud Speech, and more. So now the very first thing is with audio file as source. The audio file is what? This audio file. With audio file as source, I am saying audio file recognizer dot record. So now the very thing is that this, as you said, that when I type the audio file is the type of this is audio file. But in order to do this order, in order to convert or do all these things, we have to convert this file into audio data. So that thing here, it is converting it with the help of this. Now the another thing is the recognizer dot recognize Google. So now this is the main thing. This is the library. This is my library. So now there are different libraries. When you'll see here, this is the common this is the Python page. This is the Python page where the speech recognition library is there. Then there it is written the recognizer class. Now there are different APIs that recognize Bing, recognize Google Cloud, recognize Hondify, IBM, Ping, Spit. So now we are using this library. Okay, recognize Google, because this is a Google's web speech library which is free. Now Bing is recognized. Bing is of cost. Google Cloud is of paid. IBM is also of paid. These are pretty good libraries, but these are paid. Now in order to demonstrate all of these things, what I am saying is I am just using this free library. Now it is not that bad, but the thing that which are working, or the files which are more of paid version, they are obviously good, right? It happens. So now what I'm doing, I'm just saying recognizer dot recognize Google audio data is equals to audio file. So now what has happened here, I've just said, okay, recognize all the text which I am doing. Now I have to do nothing. What this file will do, it will automatically recognize I am storing that in the form of result. Now I have run it. Now it may take a few times, 3 to 4 minutes to run, because it will work on net. You have to have an internet connection for it, because obviously it is connecting to an API. So you have to have an internet connection. It may take 2 to 3 minutes to get the results. Now when I see my result, so okay, so how, see, everything which the words were spoken, everything the words which were spoken, now I have converted into text. If you want to listen, if you want to see what were the words, see, one second. If you want to see what were the words, so this is my words. Okay,
Then
you can
awesome. Okay. Would you
can
be
check
then locking this meeting in so that we
logging this
don't
meeting
have
in
more
so
participants,
that we
because once
don't
the
have
division
more
of team is done and stuff like that?
Okay, so now maybe it can have some errors, like when she did stuff like that, it is printed a structure. Okay, so it can happen because obviously this is a free API, so it can take a little bit time, or it can take a few errors. But the thing is, the percentage of error will be very less. The percentage of error will be very less, so you can manage working on it. But if you want to have a full accuracy, you can always use the paid APIs. I've already told that these are IBM speech to text, CMU Sphinx, Google Web Speech API, Google Speech API, and more. All of these things are come under this recognize column, which is the recognize Bing, recognize Google. These are the different commands to use different APIs. So this was the thing about reading at the API. Now there are different functions how you can read the API. Now as I have written here this, okay. So now the thing is, if you want to see that, okay, I only want, this is around 3 minutes, okay, but you say that I only want to use the audio file of, let's say, 5 seconds. So what you'll do, after this source here, you'll say, okay, duration is equals to 5. That means it will just select the first 5 seconds and the only of that and it will give the text for that. Okay, so this is the reason for that. Now I am not again doing that, because in order to again run it you have to basically kill all the restart the kernel, because it is already stored in that memory. You just have to run the same similarly the way I did. So it will now in this section what will do, it will just run the first 5 seconds. Okay, the or other any duration you give. Now the another parameter is the offset. What is offset? This is used to cut some part of the starting data from your audio file. That is, if you don't want the first 2 seconds, right? Like if I that in similarly in that the lady was saying some lady was not saying any word and you don't want that connection. So what you can do, you can select the offset is equals to 2 and the unit is seconds. So it what it will do, it will skip the first 2 seconds part and then start recording from the another 2 seconds. Okay, this is the work of offset. So by these two parameters you can basically you can basically manipulate. You can either use them individually or you can combine them both. This is a very simple command, the very simple command. Now it will now it may have I'm not again running it because I have to again restart kernel. You can do it on your own by restarting kernel again and again. It is a very simple procedure. This will be the result. Okay, so this is how you run. Now the last thing which is left is the effect of noise. Effect of noise. So now what happens is now what happens is in the noise sometime now this in this audio file there was no noise because it was the person was directly speaking and all the saying. But sometimes it happens is when one is speaking there is a huge amount of noise. Okay, there is a huge amount of noise and it is not able to identify what is there. So what you can do, you can just say recognizer dot adjust for ambient noise. Now what you have done, you have already told, okay, I have my noise, so basically adjust it according to that. Only take those things which my main speaker is saying. Okay, which my main speaker is saying. So by that way my noise will be reduced. So that only that procedure is same. Why that you'll do that. In this we don't have much in this we don't have much results or any other thing. As you see, this is the result and there is not much difference because we didn't had any noise. Okay, we didn't had any noise, so that's why this had no difference. But if your audio file is containing noise, there are several different speakers speaking and you only want to select one, then this noise is a very good feature. So this was all about the speech recognition, basically how you can recognize that speech and how you can convert all of these things. So now in the next section what we'll see, in the next section we'll see how we can do the text analysis. We can use the text analysis. So this will be the section in which we'll be seeing how we can do the text analysis. That will be the last section. Then I'll be telling that what are the different applications which you can do with the help of this. Hello all and welcome to the next section of our project. So now in the previous sections we have seen the introduction part for the speech recognition. What is speech recognition? What are the applications of speech recognition? And what are the different APIs present? Also we saw that we used different APIs and we had different parameters like the offset and the duration, how we can hinder the files which you want to record, and what is the difference between an audio file and an audio data. Audio file is basically the natural type of file which we record and we have to convert that into audio data with the help of this record function. So with that, in order to record our files into text, and after doing all of these things, this was the result which we got. This is basically the words which are spoken, which the speaker had spoken from that results from that audio file. So now as you said, this is in the form of a string. Okay, this is a string. Now what we have to do, we'll see that how we can, this is a string, but now you'll be wondering what to do with it. How can I convert this? Now what we'll be doing, we'll be splitting this string on the basis of the space. Okay, these are different space, right? So we'll be splitting this string and converting it into, first we'll be splitting and converting into list. Okay, so now what I'll do, I'll just say result dot split and it will just split it. Now when you'll see, it is converted into a list and each and every word is converted into an element of a list. Now if I want to see, I want to see the first element. Okay, I'm saying give me the second element. Okay, give me the first element. Awesome. See, this is how it is. Now, when I say this is the whole string, okay, these are the whole string. Okay, these are the words which we have spoken. So now, what you have all the number of words, each and every word separate. Now you can do anything you want with it. Like if I want to see what are the different number of words used, now what I'll just say, okay, print unique words, and there's a command called set. What it will do, it will give me the different number of unique words which we have. Okay, these are the different unique words. If I want to see how many words are there, I'll just say that number of different words used is length of unique words. I just there are 135 unique words used. So now how easy it is, okay, how easy it is to work in Python and when you have all the libraries. So now the next thing is, if you want to count what is the repetition of words, what I'll do, I'll just first create a dictionary in which I'll just enter all of those words, and with that the key, the value of that key, my word will be my key, and the value to correspond to that will be the value. Suppose it is 1, that means the word is repeated one time. It is 0, that means, oh, it is 0, it cannot be 0. First what I'll do, I'll just create a dictionary with all of the values 0 to it, so that I have a dictionary with all the words, right? So what I'll just say dictionary, then I'll say for word in result string, each and every word dict and word, because that word the value is 0, so all of the values are 0. Now what I'll do, I'll just say for again, I'll for word in result string, word dictionary is equals to this. Now if it is same, it will just add it plus 1, it will just add it plus 1 whenever it will come. Okay, now see. Okay, so now then is coming 3 time awesome is coming, 1 time oko is coming 3 times, so each and everything. Now what you do, if you want to convert it into a data frame, if you want to convert it into a data frame, I'll just say, okay, count df, I'm telling count df, then I'll say pd dot data frame from dictionary, because this is a dictionary, and I'm just saying convert that dictionary into a data frame. I'll just say work dictionary orient is equals to index, that is basically it will be the index which I'll be taking. Columns is equals to call, the column I have already told, okay, repetition will be my column. Now if I want to see my count df, if I want to see my count df, so this is my count here. Now the thing is, we have this as an index, but we don't want this as an index. So what I'll just do, I'll just say reset index, and I'll say index this index name, because the now if you'll see what it will show, I'm just saying index because as it was index, that's why the name is coming index. I want to remove this also. Okay, I'll just say da count df dot rename index to word. Okay, see how it is done. Now we have a complete perfect data frame which is telling us that, okay, this is the word and this is the number of repetition to it. Okay, this was the whole idea. And see that if you this is how you perform an EDA and a Python task. You count, you see one by one your mistakes and what are the different changes. What I would suggest it, like I am doing, I am just checking what are the changes happening step by step. That's why I'm able to see, okay, this is my mistake, this is how I can do or see that whole thing. Now the next thing, if another thing what we can do is counting the number of words spoken per minute. Okay, counting the number of words spoken per minute. For that, it will be a very simple logic. Like if I have a total number of words, okay, and I know that the length of the audio file is 3.0, and if I will divide that number of words by total length, I'll have the length of words per spoken per minute, right? I'll just say the length of auto is 244. The total length is 3.08 minutes. I'll just divide it. Then the speed, the total number of words spoken per minute is 79.22. That is approximately 79 words spoken per minute. See how easy it is. So this was an idea of total text characterization using speech recognition with all of those things. So now there are different things. So this was a very short audio file, and this was a repetitive or basically a stored audio file. Now what you can do is you can basically start recording your own file. Like here I have used, let me show you. Here I have used recognizer.record and I'm saying source, but the source here is basically the audio file. I'm saying with audio file as source, but the source can be anything. It's the source can be your the microphone, the source can be your microphone, the source can be the noise admitted around here. So you just have to import another library to understand or to do the import, to take the audio input, and it will just serve as source. Now it will, you can make a complete application. You just say the word and it will automatically tell you, and then in the backend you can perform all of these applications. Okay, you can create a wonderful application, like when you say I am creating an application which is called analyzing the words. In that, what will happen, I'll say the word and it will automatically catch all those words, and it will tell me what are the different counts of words, what are the different things happening, what are the different vowels, each and everything it will tell. Okay, so this is how you can build an application. So this was a basic idea behind it, how you can do all of these things and create or take different audio file, record some audio file, so you can directly speaking and see that okay, what are the different things can you do with it. And I hope you like it. This notebook will be provided to you along with that example file. So see it, explore to it, and do more projects like it. Thank you.